Hey guys. Sorry that I couldn't go through this with you in person today, but I'm going to go over it with you on the review sheet. So hopefully that is as good. If not, guys, please feel free to reach out to me on Remind and I can hopefully answer any questions that you have. So let's go through these review problems. For number one, they're asking us to factor, just factor, not solve, just factor. And this is our traditional quadratic form. So in our head, we're thinking of two numbers that multiply to give us 18, but also add to give us -9. So when I think of 18, I think of 1 and 18, but that's not going to work out. I think of 2 and 9, but that's not going to work out. And then I think 3 and 6. And yeah, 3 and 6 will work because, I'm sorry. If we change them to -3 and -6, that'll work out because if I have a -3 times a -6, that'll give me positive 18. But if I have a -3 plus a -6, that'll give me a -9. Then I'm looking for that middle term. And so we factor this as n minus 3 times n minus 6. If you happen to have n minus 6 times n minus 3, it is the same thing. We're all good. All right, let's take a look at number two. For number two, this one is factoring and it is still the quadratic form, but it's going to be one of the ones where it's a little bit harder because you have that number in the front of the problem. If you have a number in the front of the problem, we're going to use that X method that we learned in class. So the way we do that is we take the number that's the coefficient in the front here, we multiply it to our constant in the back here. So 5 times -4 is going to give me -20. And here's that X method that we were talking about. So we're going to look for two numbers that multiply to give us -20, but still add to give us the middle number here, which happens to be a 1. So I'm thinking about 20. I'm thinking 1 and 20, 2 and 10, 5 and 4, and there we go. 5 and 4 will work out. If we make the 5 positive and we make the 4 negative, well, 5 times -4 will give me -20, but 5 plus -4 will give me that positive 1. So we're going to go with the 5 and the -4. Now, remember with this X method, the next step is to go ahead and take this number that's in front of our problem, that coefficient, and we're going to divide each of these numbers that we came up with by 5. And you can see me with the arrows going down here, me reducing it. So 5 over 5 reduces to 1 over 1. I do leave it as a fraction because we're going to use the top and the bottom. -4 over 5, we're just going to leave that as -4 over 5. And again, we're going to use the top and the bottom at the next step. So in the next step, the bottom of the fractions become our coefficients that are in front of v. So I have 1v here. I just didn't write the 1 in front. And I have 5v over here. And then the numbers that are on the tops of the fractions are going to be what's attached by addition or subtraction. So that's why I have +1 over here. And that's why you see I have -4 over here from this fraction. And then this expression is this factored. If you're still unsure if you did it right, you can always multiply it back out and see if it gave you the original expression. All right. So for the next set of problems, we are expected to solve. So that's why these problems do have an equal sign. And when we are solving by factoring, we do want to make sure that it's set equal to 0. So for number 3, we're good. And this is our traditional what two numbers multiply to give me this, but add to give me this. So I'm going to think about all the different ways, and I come up with +5 and -7. That'll multiply to give me -35, but add to give me that -2. But now we're going to take it a step further. We're going to go ahead and set those two expressions or factors equal to 0 because we're going to use the zero product property. And so when we do that, we can go ahead and solve. We're just going to subtract 5 on this side, so we get -5. We're going to add 7 on this side, and so we get +7. Okay, for number 4, it's a little bit harder because we don't have this set equal to 0. I hope you noticed that. But it's very easy to go ahead and fix that. All we're going to do is subtract 7 from both sides. And now we have an expression that is equal to 0. And this is, again, your traditional quadratic form when we're factoring. What two numbers multiply to give me 9, but add to give me -6. That's going to be -3 and -3. And then you can set the expressions equal to 0. This is a rare case, but it happens that they both end up being 3. That can happen sometimes, but typically we have two different answers, but that can happen. So that's why you just see the 1, 3 up here. All right, for number 5, we are lucky that it's already set equal to 0. However, this is quadratic form, but it's one of those problems where we have the number in front, and similar to like we did above, we are going to have to do our x method that we've talked about. So we're going to take the 9, multiply it to, I'm sorry, we're going to take the 2, multiply it to the negative 9, and that's where the negative 18 came from in my x method here. And the negative 3 came from here because I want two numbers that multiply to give me negative 18, but still add to give me that middle number of negative 3. So I came up with negative 6, and positive 3 will multiply to give me this, but add to give me this. And as discussed before in the x method, we always take the coefficient that was in front of the problem here, and we divide these by that 2. Now, you see me with the arrows and I'm reducing. Sorry, I kind of went into my work for my other problems here, but I'm going to end up with negative 3 over 1 and 3 over 2. And as discussed before, the bottom numbers become the coefficients that are in front of our variable. So I have 1x and 2x. The numbers on the top become what's attached. So I have minus 3 and plus 3. And I'm sorry, I kind of squashed in there equals 0 because I was running out of space over here for this problem. And then I'm going to go ahead and set both expressions equal to 0. So either x minus 3 equals 0 or 2x plus 3 is 0. And I didn't show it here because I was squishing things in, but I would add 3 to both sides. So that's how I get positive 3. And on this side, I'm going to go ahead and subtract 3 from both sides. So I have a negative 3. And then I'm going to go ahead and divide 2. And you can see me squishing over here. It's going to equal negative 3 over 2. So those are the two answers that you get for this problem. Okay, let's take a look at number 6 and 7. For number 6 and 7, we're simplifying. We have square root problems, also called radicals, and we're going to see if there's any perfect squares trapped inside. So for 8, I'm thinking of ways to multiply 8, and when I think about 8, I think about 4. 4 goes into 8, and 4 happens to be our largest perfect square. So I'm going to break 8 up into 4 times 2. And when I take the square root of 4, which I can, that becomes the 2 that goes in the front without the square root symbol. Once you take the square root, you don't write that symbol anymore. But for this one, I could not, so that stays trapped inside. And there's no perfect squares trapped inside that. So it's just going to be 2 root 2. Okay, for number 7, I think the easiest way to do this problem, although there are a couple of different ways to do it, is to go ahead and multiply these two numbers. So 6 times 8 is going to give me the square root of 48. So you see it here and here. But I had a couple of my classes give me different methods of doing this. For one class, they were kind of stuck on trying to find out what perfect square was trapped inside. And so they went with 4 at first. But once we broke it up into 4 and 12, we were like, wait. Isn't there another perfect square trapped inside of 12? And we were like, yeah, 4 times 3. So they actually broke it up a couple of times in order to get to our final answer, which is 4 root 3, which I discussed in class that sometimes you can do it like that. However, if you were able to find the largest perfect square that is trapped inside of 48, which is 16 times 3, then you could get to this answer a little bit quicker. However, we still get the same final answer, so whatever works for you is going to be the way that you should do this problem. All right, let's go to the next page. On the next page, I have 2 over the square root of 3. It's a fraction. And with fractions, we are not allowed to have complex numbers in the denominator. And square roots are not allowed in there. That's considered a complex number. So we've got to get rid of it. How do we get rid of it? Well, the only way we can get rid of it is we take the square root. And we can't take the square root unless it's a perfect square. So how do we make it a perfect square? We multiply it by itself because that's what perfect squares are. So we're going to go ahead and multiply this by the square root of 3. But whatever we do to the bottom of a fraction, we have to copy and paste and do to the top of the fraction because that's how it's math legal. So we're going to go ahead and multiply. When we multiply fractions, we multiply across the top and across the bottom. So I have 2 root 3 on the top, and I end up with root 9 on the bottom, which now I can take the square root of, which is 3. So we end up with 2 square root 3 on the top over 3. Be careful, do not cancel it with this. This is a square root, this is not a square root, so they are not friends. However, if your outside numbers can be reduced, you should do that, and we've had problems in our notes where we did do that. All right, let's take a look at number 9. For number 9, for 9 and 10, I have to solve by taking square roots. So we're just going to do our traditional solving methods. Please remember when we solve for x, we do the opposite of the order of operations, PEMDAS. So we're going, addition and subtraction first, then multiplication, division, then exponents, then parentheses, because we're going the opposite of PEMDAS to undo the problems. So here we're going to go ahead and divide first, get rid of that 5 by my x, so I end up with x squared equals 4. Then we're going to take the square root. Please, 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 it's very important in these problems that you remember when we take the square root, you must do both the positive and negative roots. If you do not do that for these problems, you're going to get major points off because that is the whole thing that you're getting tested on for solving by taking square roots, to remember that point. So I get, so once again, the answer for this is going to be x equals both positive 2 and negative 2. For number 10, we're going to try to get a by itself. So the first step is to go ahead and move that 4 over. So we subtracted 4. Then we're going to go ahead and divide by 4 as well. And so we end up with a squared equals 25. Then we're going to go ahead and take that square root finally here. And we end up with a equals both positive and negative 5. All right, 2 more problems. For number 11, we have to find the value that's going to turn it into a problem that we can take the square root of that makes it a perfect square. So we're getting ready to do problems by completing the square. Please be careful. There are 2 parts to this problem. The first part is to find the value. In order to find the value, we take whatever the middle number is, typically your b, and you're going to divide it by 2, and then you're going to square that expression. So we're going to do negative 20 divided by 2 squared. So that's where I get my negative 10 from, and I square it and I get 100. So 100 is the number that's here that's going to turn this problem into a problem that I can factor, and it'll be a perfect square. So let's do that because that's the second part of this problem. So I just rewrote this over here so I had a little bit more space. And people who are still having trouble with this concept, please look back at number 1 and number 3 and number 4 when we factored those, because it's still kind of like that. You're still thinking of what 2 numbers multiply to give me this, but add to give me this. Well, negative 10 times negative 10 will give me a positive 100, but a negative 20 when I add them together. And since it's exactly the same expression, I can write it as a perfect square. And that's what we do want to happen. These will always end up being a perfect square. However, I did tell everybody that the kind of cheat, as long as you know it, is it'll always end up being your middle number divided by 2 will be what is the number that's going to get attached in the parentheses here. Okay, so number 12 says to go ahead and solve this problem by completing the square. Now, just a little warning, I understand that this problem could be solved by factoring. I know that. I made it that way because I wanted the numbers in your problem to be nice and not turn into nasty numbers for you. And the only way I can do that is giving you a problem that could have been solved by another method. However, the directions say they want you to solve by completing the square. So you have to do it that method. When you do it that method, typically this number would not work for the problem because typically it would not be factorable and you would have to move this over to the other side. I know that is not true for this problem, but I did that on purpose so you can have nice numbers. But let's go ahead and do our completing the square method. So we're going to move this over. So that's why you see me adding 7 to the other side. And then we're going to come up with a number that's going to make this, typically it would make this factorable because before it wasn't, but that's not true here. But it's going to make it factorable in such a way that it's going to be a perfect square for us. So we're going to take our middle number, negative 6, we're going to divide it by 2 and square it, and that's going to give us 9. 9 is going to make this number work, so that way we can solve by taking square roots. So we're going to add 9 to both sides, so that way it's math legal, because what you do to one side, you must do to the other. So now I have this expression. So I have 9 here. Make sure that you change this to 16. And now this is factorable. 2 numbers that multiply to give me 9 and add to give me negative 6 are going to be negative 3 and negative 3. And so now I could write it as a perfect square problem here. And I can solve it by taking square roots. So I'm going to take the square root of this expression. So I'm going to get m minus 3 equals both positive and negative 4. And then I'm going to go ahead and add 3 to both sides. Remember, I told you I want you to write it in the front, so that's why you see 3 plus or minus 4 here. And since we were able to go ahead and take the square root and we have a value here, we're going to calculate the final answer. So we're going to do either 3 plus 4, which gives us 7, or we're going to do 3 minus 4, which gives us -1. And that's the end of this. So if you guys have any questions, please reach out and message me on Remind.